Okay, so a one-dimensional array. We've seen this as a list before, but it can also come as an array. This has elements within it, which are these 1, 2, 3, 4, and 5. This one-dimensional array has one dimension, really, which is a length, or 1 row and 5 columns. A 2D array, on the other hand, now adds another dimension. This can be looked at as length and width, or row and column. Now, a 3D array gets tricky. In Python programming, or programming as a whole, this is normally looked at as a 2D array duplicated a lot of times. For example, it looked like this. Imagine all these purple squares were also the same array, and now it adds a sort of layer of depth. Okay, so now that we've gone through the animation, we can look at making our first arrays within Python. So the first thing I want to do with this is import a package called Numpy. So the Numpy package within Python allows you to create arrays with ease, and not just arrays within one dimension, but for n dimensions, so 1, 2, 3, 4, and so forth. So predominantly in this tutorial, we'll only run through mainly 1D and 2D because they're the most commonly used. I will show you how to create 3D, but I won't go into depth about 3D arrays because most arrays you will come along to see within programming will be 1D and 2D most oftenly. So to import Numpy, we just have to write import Numpy as np. If you don't have Numpy installed, and if it didn't come pre-installed to the IDE that you're using, I think that might happen with some IDEs now because Numpy is such a popular package. But if not, you can just install it via the CMD if you're using Windows, so the console. You just have to run the console as an admin, and then on the internet just look up for Numpy install code line. Should just be a one-line piece of code that you type into the terminal, press enter, and it should install Numpy for you. And then you can import it just like we've done here. So if you haven't done that, go do that first and come back here and you can go from there, because otherwise Numpy won't work for you. So once we've imported Numpy, we're going to call it np within this program. So whenever we want to call a Numpy, we are going to call on the letters np because that's what it's being called within this program. So to create an array, first we just want to start with creating a variable called array. So I'm just going to make that right now. So this is just a variable named array. Obviously it doesn't have to be called array, but I'm just going to call it array because that's exactly what it's going to be. So to call a Numpy, we're going to write that np dot, and then you want to do array. So now we're making a Numpy array. So in here you can practically just structure your array. So they get structured just like the inbuilt structure into Python I've shown you before, a list, as far as 1D goes. So let's just make this 1, 2, 3. So now we have a Numpy array, which is one dimensional, which has the elements 1, 2, and 3. So if we print this array to the terminal, we can see what we get. There you go. We get the 1, 2, 3. So that's our array. The big difference, as you can see when this is printed to the terminal from lists, is the lack of commas. So it's not comma separated. It's static elements that have white space in between them. That's, I guess, the sole difference you can use to identify if someone's using the inbuilt list data structure in Python, or they're using an array structure, whether it be of Numpy or a different package. So the next thing I want to do is to go through a 2D array. So the array that I would say is most commonly used within Python. I would say one-dimensional arrays are quite common within other languages because some of them do not have a list as an inbuilt structure within the language, so they have to use an array to achieve what a list achieves within Python. But because Python has a list and it is quite functional in itself, normally when people want to do one-dimensional array type things within Python, they'll just revert to using a list instead of coding up an actual one-dimensional array. But as soon as they need a 2D list, that's not really conventional. So we have to move to an array. So a 2-dimensional array, and that's when arrays come in. So a 2-dimensional array, as the animation showed us, has a row and a column dimensions, or if you want to look at it in as how the visualization had it, it's a length and a width. So rows and columns. So obviously this 1-dimensional array we have here only has really one dimension, which is length. So it has a single row with 3 columns, but it's that single row that's making it 1D. So as soon as we have more than one row, it's more than one dimension. So to create a 2D array, all we have to do is put a square bracket and then another square bracket, because the outside square brackets are defining that these inside 1D arrays are part of a bigger 2D array. So we can just make our first row 1, 2, 3, and then a comma, and then another 1D array, and we're gonna make this called 4, 5, and 6. So you want to put these within the outside square brackets. So now it's a 2D array that is containing 2 1D arrays that we have given it, which is 1, 2, 3, and 4, 5, 6. So if we print this, you see what we have in the terminal. 1, 2, 3, 4, 5, 6. So there you have it. That's a 2-dimensional array. So I think the next thing that I want to move on with is calling on elements within an array, within a Numpy array. Now, this is done quite simply and pretty much quite similarly to a list, if not near identical. The easiest way to do this, there is long ways through iteration, where you iterate through the rows and then you iterate through each, let's say, column within that row. But because Numpy is a great package, you can call on them just with slicing models or slicing index calls. So if that doesn't ring a bell, this is what they look like, and you should remember how these kind of look from basic Python stuff. Whether you watch my Python videos on strings or you learned it elsewhere, they definitely would have covered slicing within that portion of learning Python. So to call on an element within this 2D array, I'm just going to make a new variable called element, and then I'm going to write array because that's the array we're calling. So we're calling this variable, which is storing our array, and then it's square brackets, and then it would be another square brackets. So in the first square brackets, you're going to want to have your row index, so the index of the row index that you want to call upon, and the second square brackets is the column index. So if you want to look at this in math terms, your first square brackets would be an x coordinate and your second would be a y. So we can call on 0 because this still stays true to how a computer CPU counts, which is including 0 as its origin but also a start counting value. So if that doesn't ring a bell, that's basically if you gave the computer 3 items, it would tell you that it has 2 items, and it would call the first one 0, the second 1, and the third one 2. Where giving it to a human being, they would say they have 3 items, and the first one is 1, the second one is 2, and the third one is 3. So stay true to that. To call on the item that most humans looking at this array without computing experience or even with computer experience, would say this is row 1. To get the same result from the computer, we're going to have to tell it to call on row 0. So we're calling on row 0, and let's call on index 0. So in reality, we're going to get the item at row 1 and column 1. So once you've done that, you can just print this element, so print the variable. And if we run this, you can see what we get. So we got number 1 in the terminal. So this is the element we got, and that's exactly the one we were intending to call on. Now, some other things to abuse slicing a bit and use it to our advantage is you can also just call on the entire items within one row. If you just put a little symbol like this here and leave it open to the other side, it will go from 0 onwards to the end. So that's how that works in slicing. So if we can run this again, we get the whole first row, or the whole first one-dimensional array within the 2D array, which is this 1, 2, 3. Okay, so moving on from this, I want to quickly show you a 3-dimensional array and how Numpy handles that, and how they appear within the terminal, I guess, because it's not all cuboid like and 3-dimensional like as kind of the one I try to display within the animation. It's more or less just, it kind of just is having like the same array multiple times. That's how you'd visualize a 3D array within the terminal with Numpy. So this time, because writing out 3 actual arrays would, be a bit long and tedious, I'm going to show you a model within Numpy. So this is called the Numpy Zeros model. So this will create us an array full of zeros. So every element in the array will be a 0. So when you call upon this, it needs 3 dimensions, and it's not meant to be 3. Don't think that it always has to be 3, but obviously to get a 3D array, we need to have 3 dimensions. Just like in mathematics, for something to be 3D, it has those significant 3 dimensions. Normally X, Y, and Z, or when the dimensions get even higher than that, they normally get subscripted, as in x1, x2, x3, and so forth. So to do this, you want 2 brackets, because it's a function call out on the outside bracket, and the inside it is the structure of the array that we're building, right? So the first number will be the z axis, the second one will be the x, and the third will be the y, I believe. I might be wrong here. I'm going to run this and see if that works. So we should have, we'll just change that to get it. We'll just go with a 3 by 3 by 3. So we should have 3 2D arrays with 3 rows and 3 columns each, with all of element 0. So if we print this out, see if we got it right in the terminal. There we go. We got those 3 arrays. So now there's 3 identical arrays. So that's how 3D is kind of looking like in the terminal and within Numpy. And you can also index call a 3D array in the same manner. You just have to add that extra dimension or index call. So now it is calling on 3 position points instead of the 2 from before. So that works with every dimensional array. If you had a 4D array, you would obviously have to call on 4 positional points, or coordinates for that matter. And if you had a 5D array, you have to call on 5, and so on. So if we call on 0, 0, 0, we should get the element in the first row and the first column within the first array. So we print this, we get a 0. So obviously we got 0 anyway, because all our values within all these within all the arrays within this 3D array are 0, but you know, that's how you index call a 3D array. But rarely will you use that. 2D is a lot more common, but yeah, if you see any code in a code base like this, it's a 3D array. So that's about it, guys, for the basics of arrays. Now this was the real basics of arrays and just how they're created, and so you can kind of recognize them if you see them within any code base, or especially NumPy arrays for that matter. As soon as you go into another language, NumPy is no longer in use, so arrays might differ in looks or structure within those languages, but the properties of them stay quite the same, so that's good. So you have that knowledge, and hopefully you can put it to good use from now forward. In the next video, we'll be learning about classes, and then hopefully building ourselves our first medium-sized kind of project using classes and structures that we learned all in previous videos, including the arrays we learned today. So apologies if you were looking for a kind of putting arrays into practice type video today, but that would have made this video very long because I would have had to run through the basics and then run through actual coding examples and where arrays can be used within problem solving and coding. But stay tuned, the next video we'll be building a mini program to display how classes work, where we will use arrays to be functional and do more than just creating them. So if you enjoyed the video, leave it a like for me, that'd be awesome. If you didn't like the video, leave it a dislike, just as awesome. It can help me improve on the things that weren't so great, and hopefully next video I can have them even better. So once again, thanks for watching, guys. I've been Sxlly, and I hope I can see you in the next video where we'll be covering classes.